This is the part where we'll do our calculations and see if momentum has been conserved in our experiment. So the conservation of momentum tells us that the initial momentum should equal the final momentum. And remember, momentum is mass times velocity. So we're hoping that the mass times the initial velocity will equal mass times the velocity final. So what we're going to do here is we're going to split it up into our, I'll first do vertical, into our vertical components, and then over here when we're done, we'll figure out horizontal momentum. So let's first look at momentum in the vertical direction. So in the vertical direction, initially, we'll use the ball that did not make a collision. And I've already calculated that the mass of the ball in kilograms of each ball was 0.00842. So we'll say 0.00842 times, and then the velocity of the ball that did not collide, we calculated was 1.13. And we want that to equal, and now we'll calculate the momentum in the vertical direction of the two balls that collided. So in this case, we're going to be adding up two momentums, the momentum of the first ball in the vertical direction and the momentum of the second ball in the vertical direction. So the mass, again, is the same. And ball one in the vertical direction, its speed was 0.8733. Then we'll add the momentum of the second ball in the y direction, and its mass was 0.00842, and we calculated its speed in the vertical direction to be 0.503. So we'll do this calculation and see if momentum has been conserved and how much our error is. So we'll figure out the momentum of the ball that did not make a collision. And that is equal to 0.009551. We'll do it to 3 sig figs. And on the other side, get 0.0116. And both of these are in kilograms, meters per second. So you can see here they're pretty close. Now let's do the same thing in the horizontal direction. For our first ball, we had a mass of 0.00842, but then we talked about for the first ball it did not have a horizontal component, therefore its speed in the horizontal direction is 0. So we'll end up getting 0 on our left side. Now for our horizontal component of the other balls, for the first ball, we had a mass of 0.00842 and a speed of 0.0611. And then we'll add it to the momentum of the second ball in the horizontal direction. Same mass. But this time we have a vector going to the left, so we'll have to use negative 0.393 meters per second there. So now let's add these two and see what we get. So here we get negative 0.003. And that is kilograms, meters per second. So once again, you can see that those are very close. So not too much of an error, which I hope tomorrow when you do this lab, you'll find the same thing. You won't have much of an error. Also, as part of your lab tomorrow, you'll also have to do the kinetic energy of the balls. And the reason we do that is when we study kinetic energy to see if kinetic energy has been conserved, you want to determine if it's an inelastic or elastic collision. So you'll be doing kinetic energy tomorrow as well, in addition to the conservation of momentum. So make sure you're ready to go tomorrow, and we'll see you then.